To Hadoop exam learning resources. In this session, we are going to discuss yet another resource negotiator, that is Yarn. So in this, we will discuss the various components of yet another resource negotiator, new Hadoop framework, that is also known as MRv2, that is MapReduce version 2 can be executed on Yarn. Then we will revisit our older Hadoop framework 1.0, where we will see the various older components which was used in Hadoop framework previously, and then later on we will discuss the difference between these two architecture and how Yarn fits in this overall architecture. And at last we will also discuss why there is a need for non-MapReduce framework. So let's start with the first introduction part. So let me clean out the screen first. Yeah, so let me write down the title here first. Okay, so what is this? As part of introduction, what I wanted to say is that Hadoop framework is like MRv1 and MRv2. There are two versions has been introduced. So that's MRv2 is like based on Yarn, that is yet another resource negotiator component. So here MRv1 and MRv2, with the introduction of this new Yarn architecture, MRv1 does not goes, even whatever you have written in MapReduce older version will also work on the Yarn framework. So this is always remain backward compatible. It doesn't mean like using the new framework will you have to write the new MapReduce code. So your older MapReduce code still work with the new architecture of Hadoop framework, that is Yarn. So this is up to CDH2 you can say it was MRv1, but from the CDH3 onwards, like right now it's a CDH5 exactly. So this Yarn architecture has introduced. So these are new enhancement up to CDH5, which include many other features than Yarn. So that is the main difference between older version and new version. So, and this is always remain backward compatible. So let me first discuss regarding some basic component of the Yarn architecture. So basic components of Yarn. So that is first component which we are going to discuss, that is resource manager. I'm just going to write RM. So what exactly resource manager? Resource manager is acting purely as a resource scheduler, which is the sole arbitrator of cluster resources. So whatever resources in your Hadoop cluster, so let me say this is your Hadoop cluster. Okay, so this is your Hadoop cluster with various nodes in this. Okay, this is your, and this is the client machines, which could be many clients over here. They are submitting jobs to the this your Hadoop framework. So now there is a central component in this. That central component, I would say, this is resource manager, is responsible for distributing this resources among this from this node, like which node would be used by and which part, how much memory and CPU from each node would be used by which job, is the responsibility of resource manager to allocate the resources to each job from out of this cluster. So let's assume it just blindly, we will say numerical ways. There is 100% cluster available. Out of 100%, this job can acquire maximum 20% of resources, and this job can acquire maximum 30% resources. And if new client comes in, whatever. So how this resource distribution happens, that is different, depend on many other factors, but I just want to explain you the responsibility of the resource manager. And the remaining 50% might go in this third job. So this is so who decides how much capacity should go to this each job, and that this also depends on the jobs, like the submitted by the job. So that the job needs more memory, then resource manager, they have to ask resource manager to give to get more memory or more CPUs or more disk space, whatever is needed. So resource manager is purely responsible for distributing the resources among the job in the cluster. So let's assume it you are running a 3 MapReduce job, I would say, that is MR1, MR2 and MR3. This 3 MapReduce you have submitted. This job needs 50 GB RAM, 4 CPU, and let's assume it 50 GB or not 100 GB disk space. Similarly, this job needs 20 GB RAM, 8 CPU, and whatever say 80 GB disk space. And this job needs 20 GB RAM, 4 CPU, and 40 GB disk space. Okay. So now the resource manager, which is the central component over here, is responsible for distributing from your cluster to the cluster the resources accordingly. Suppose this MapReduce one this much memory, 50 GB RAM. This is memory intensive job. So this job will ask resource manager, give me more memory because I'm memory intensive job. So resource manager we will allocate the resources like 50 GB RAM, 4 CPU from the cluster to that job. Similarly, this job is CPU intensive job, so then resource manager, this job will ask for the higher CPU. Then resource manager look for the cluster and which is the best possible way to get such resources and allocate to them. And this third one is average job, so accordingly the resource manager will distribute the resources to this particular job. Okay, so now next component out of this other than resource manager is mostly is application master. That what is this application master? So here you have submitted 3 jobs, correct? So the job would not ever directly communicate with the resource manager. So there is a in between component that is called application master 1, application master 2 and application master 3. So in general for each application means this MapReduce job is considered as a one application. So here understand there you are running 3 application, 1, 2 and 3, and each application would depend on this application master. So there are 3 application masters are running. So this application master is responsible, like this job is heavy memory intensive. So now this application master for this running this job will ask to resource manager, give me the resources like 50 GB RAM I need 4 CPU and 100 GB disk space to run my MapReduce job. So from the cluster, so suppose this is your cluster and various nodes inside this cluster. So using this 3 nodes, let's say this combination of 3 nodes can suffice this requirement, this 50 GB RAM, 4 CPU and 100 GB disk. These 3 nodes can suffice this requirement. Then resource manager will assign this 3 node to this application master, and not assign it, exactly tell the application master that you can use this 1, 2 and 3 node for running your application on the Hadoop cluster. Similarly, application master 2 will also request 20 GB RAM, 8 CPU and 80 GB disk space. So now the application master will say I am a CPU intensive, give me the resources accordingly. So resource manager will go to cluster and again identifies the node accordingly. It might be the same node which is being used by this job, first job, and can be shared by the among this. So there could be like multiple node sharing is also will always possible obviously in the Hadoop cluster, and this assigned to this MapReduce to another second job. Now similarly third job, this is average job. So resource and then application master requests resource accordingly to from the resource manager, and this resource manager will take the cluster in consideration and according to available resources and sorry, and accordingly allocate the nodes where this MapReduce job can be executed third job. So this is how application manager, sorry, not manager, keep in mind this is application master. Application manager is a different component. So the application master is responsible for running this MapReduce job on the and asking for the resources from the resource manager whichever is needed from the cluster. So that is the responsibility of the application master. So now you understand what is the resource manager and what is the application master. So application master is for running your application, resource manager is allocating the resources from the whole cluster. So these are the two components we have discussed. Now next move to the another component of the this YARN architecture, that is container. So what does here container means? So it's a container for the resources. Okay, so this is the container for the resources. So let's assume it there is a in the cluster. Okay, here we have drawn it. Let me clean it out first, then it would be more clear. Okay, so now this is your Hadoop cluster. Inside this various node, let me draw one bigger node so I can explain you this. So this node has 20 GB RAM or 8 CPU or whatever you say, 100 GB disk space, even more than that it could have, but let's say that. So now you want to run your MapReduce job. One doesn't mean this job which need 5 GB RAM, 10 GB, let's say 10 GB RAM and at least 20 CPUs, okay, to run this job, and 500 GB disk space. So now resource manager will see the whole cluster and 15 GB RAM. Obviously 15 GB RAM, it won't allocate whole 15 GB from one node. So it will say 5 GB from here, 5 GB from here and 5 GB from here. This RAM you can use it, and 20 CPU. So my each node, it's assume it 8 CPU. So it can say 5 CPU from here, 5 CPU you can use here, 5 CPU from here. So this again 3 nodes can be utilized from you for your requirement, or you can say 10 CPUs based on this, and the 500 GB disk space. So this each node has capacity of 1 terabytes. So based on available disk space on this is on from this 3 node, this disk space is assigned. So let's pick up this node from where for 5 GB RAM or 5 CPU and 200 GB disk space being used. So combination of these resources is called container. So for running your application, that this job, resource manager assign resources from various nodes, and from each node for each job there is one container, is not only one container, there could be more container can be created for a single job in a single node. So let's assume it this is like container is a collection of resources, RAM, CPU, disk space, GPUs and environment variables, many other things can included in this container. So this container are actually responsible for running your job. So each node will have multiple containers. So this is bigger node, this could have 5 containers because 5 containers are assigned more than one jobs, or could be a single job or more than one job it could be assigned. So just right now remember, container is just collection of resources. How it is assigned is completely different way it is being done. So these are the three major component we are I want to introduce first regarding the yarn. So let's revisit our older architecture of Hadoop 1.0. So let me draw this first. This is your HDFS file system, correct? This file system is distributed file system. Above that, there was MapReduce framework, and there is above that there's HBase was created, correct? Using this distributed database, as well as MapReduce is also being used. So that is HBase, or you can say NoSQL data. Above this, there is another H catalog, you can say, component, and based on this pig and hive scripting engine has been created about this, and this is another third-party component. It's not third party, it could be other component like Cassandra can interact with this, Uzi, that is self Apache component, then Zookeeper to interact this whole cluster, Avro files. So this is surrounding. So this was your Hadoop 1.0 architecture, correct? Sorry. Now where does yarn introduce in between? Where does this yarn was introduced? So let me just first discuss some points, then we'll go through this. There are some limitations with Hadoop 1.0 architecture. Okay, some limitations. What limitation? We'll discuss. There was many limitations to using. You might have realized or not, I don't know, but there are limitations. Like bigger companies has realized that older version of Hadoop has some limitation. To address Hadoop 1.0 limitation, Yarn framework was introduced. With the Yarn, now Hadoop has ability to run non-MapReduce job. So Hadoop 1.0 was capable to running only MapReduce job, but there is a need for running other than MapReduce job. So new architecture has to be designed so to impact as minimal as possible on existing Hadoop framework. There's a Yarn architecture has been introduced, so just one more component has been added between here, that is called Yarn. This component is drastically changed the overall Hadoop framework, but not too much. So this remain is the critical component of this. The HDFS still as it is. Sorry, this HDFS still remain here. This Yarn has been introduced between. So now this MapReduce is not only just not a framework exactly, it's just an applications. Now the MapReduce is not exactly as a framework, it is an applications. So now let me redraw this diagram actually, so we can understand in depth. So this is your HDFS. Above this Yarn, this is actual framework. Okay, these two components became the framework, and this MapReduce is just an application above that. Now no more exactly a framework. It's like core framework. Its core framework remains Yarn and HDFS. Now MapReduce becomes the application framework. We'll discuss. Then above this exactly H catalog and pig and hive. This is pig and hive, and other framework which is capable of like running non-MapReduce job, that is like Yarn compatible framework, you can say. I will say this is graph processing is one of the example, and this is message passing interface. This is another example, MPI, which are the other applications which are now capable of running on the what do you say, this exactly running on the Hadoop framework. Now that is NoSQL again utilize this whole infrastructure, and then finally your other zookeeper, Rosie, and so remain same. So nothing has gone exactly. It has given you the more benefit of uh, you over your older framework. So that is the where the yarn fits in overall architecture. MapReduce is just an application in yarn. How yarn fits in new Hadoop ecosystem, we have seen it. Yarn adds a more general interface to run non-MapReduce job. Okay, so what I would say is non-MapReduce jobs can be executed on the this new framework. Okay, so now let's discuss regarding MapReduce. So because still even yarn has gone to the complete different Hadoop framework change, but still MapReduce is a core. MapReduce framework is being used for this running your MapReduce jobs. Still, it's like Hadoop is majorly used by the MapReduce jobs, even though it has changed. So to understand the yarn concept, let's revisit some of the MapReduce concepts in short. MapReduce can be broken down into the following components. So first I would say end user MapReduce API. That API means like your mapper class, your reducer class, your combiner class, or your partitioning class. So these are the API classes which you might be aware because you are getting this training. So and then next is like MapReduce runtime. Second is like now this classes and framework is there, but how this has to be executed. So that is runtime environment to execute your mapper, reducers, and everything, which is like create your map phase. If you remember from our professional training, if you have subscribed that. So now next is or you might be aware from the older version of Hadoop framework, sort, shuffle, and merge phase is the part. Then next is the last is a reduce phase. So MapReduce, you remember, like the first is map phase, then shuffle phase, and then comes in reduce phase. So this is overall step where how Hadoop framework runs your jobs from step by step. MapReduce framework itself, which is the backend infrastructure required running MapReduce, manage cluster resources, and scheduling in thousands of jobs. So this is whole MapReduce framework which is responsible of doing this thing, and high level of components of MapReduce one we are going to discuss now. So now this is what exactly MapReduce in short we have discussed. So now let's see the various component of the MapReduce MR1. So components of MR1, why we are revisiting this thing, because it is very important to understand in depth each component, so we can relate with the yarn components, because yarn is replacing the older things. So this is the first component, which is called job tracker. So now this job tracker is process is the which serve as the clearing house for all MapReduce job in the cluster. So this is job tracker. I will draw the older diagram. This is task tracker. Okay, and this is another task tracker. This is, let's say, this task tracker. So whenever you submit the job, so now job tracker's responsibility to run your job on the overall cluster, Hadoop cluster. So these are the task trackers. These are the node. It's especially nodes in your cluster. So where your job tracker will run your jobs on the task tracker. Okay. So these are the two major component. Okay. So let me clean it out. So this is the job tracker. central component. This is your task tracker. On this is the node you are running the task 1. It could be running another task. Similarly, this is task tracker. This is another task can be executed. This is another task. So this is older design of the framework. So now if a client, you are a client, suppose submitting a job to job tracker. Now job tracker's responsibility submit your job on the node based on the data locality. So data locality means where the data is available, it submit your job, and accordingly task tracker will take the action and runs the job or jobs task. Each task, like task could be either map task or reduce task, would be executed on the this task using the task tracker on each task component of the node. So this is your node on the cluster, and this is client, this is job tracker. Okay, each node has a task tracker process that and manages tasks on individual node. Task trackers are controlled by the job tracker. Obviously job tracker is responsible for tracking resources consumptions. Okay, so like this job tracker is like responsible and tracking the resource consumption, job life cycle. So overall job life cycle is managed by the job tracker in old architecture. Scheduling individual task is responsibility of the job tracker, tracking the progress of the each task. Fault tolerance for this task. Fault tolerant means any task killed or goes down because of hardware failure or any other reason, then job tracker is responsible for restarting this task. So this is the way older architecture has worked. So this component. Now responsibility of the task tracker. So based on the information provided or instruction provided by the job tracker, task tracker will launch the task, tear down the task if there is any need for killing this task. Like if you remember, there is a reasons where task tracker will kill the task as well, or periodically inform, like wait till that this task is being executed, this whole information is sent to the task tracker by each task, and then this task will send this heartbeat to the job tracker. Okay, this heartbeat is submitted to the job tracker. So this is the responsibility of the task tracker. Now need for the what is wrong with this framework? Why we have to move to the next yarn architecture? So let's discuss the need for non-MapReduce. The main first reason I would say, first reason is real-time processing. So real-time processing, what does it mean? It means the stock ticker in the stock actions is published immediately. It should be available into the Hadoop cluster, and it should be processed by the Hadoop framework. So for that, this is called real-time processing. So any data which is available, and it should be processed immediately, like patient data, healthcare data, which is as soon as submitted to the system, it should be able to process that data. That is the need for is expected from the Hadoop MapReduce framework, but it was not supported previously. Now next is near real time. What near real time means? Near real time means like processing your data in every 15 minutes, every 5 minutes, or every 10 minutes kind of thing. So you collect a whole stock, whatever trading happened in last 15 minutes, and then collect this data and process this data. So this kind of facility is expected from the Hadoop framework. Now the next is graph processing, like Giraffe. If you remember, if you know Giraffe from the Apache Giraffe. So to process the graph, so to support the graph processing, was not clearly available in older framework. Now next is parallel, like not parallel, what we say, like other framework like to be supported, like other than MapReduce there is the expectations to run other than non MapReduce job, that is your MPI job, that is also message passing interface, that is iterative modeling. So this is another framework which is expected to run on the Hadoop framework, which was not supported into the Hadoop 1.0. So that's why this new architecture has been designed. Other than that, this is this is the one of the reason for supporting other framework. Now next is the second reason for like non-MapReduce is like addressing the scalability. Okay, in 2008 or 9 when the Hadoop was in the actually introduced, the then 16 GB RAM and 4 CPUs kind of and 1 terabytes of disk was a good hardware. But nowadays in 2014-15 you can say like 128 or 256 GB RAMs are supported and 16 CPUs, 16 plus CPUs, even what I would say 16 plus CPUs are on the your commodity hardware is possible, and 3 terabytes of hard disk, 12 into 3 terabytes I mean are there. So this kind of scalability should be supported by the older version of Hadoop framework, which was not easily possible with the older version of Hadoop framework. So Hadoop 1.0 was capable of 5,000 to approximate 5,000 to 10,000 nodes in the cluster, but now not even, sorry, not 4,000 node it was capable, it was tested, but now there is a need for like 5,000 to 10,000 nodes should be supported in the cluster, so which was not supported in Hadoop 1.0. So that's why there is a need for new Hadoop framework which can support this much nodes. It's because there's a need for more data is being coming up and being introduced, and that needs to be processed as fast as possible. Then fourth reason is improved utilization. So improved utilization, what does it mean? Like when your map tasks are running, so sometime then reduce slot which is assigned from in the cluster is remain empty in the older architecture, or when reduced tasks are running, the map slot remains empty. So to improve this utilizations, like somewhat that was possible in the previous version as well, but not completely, that's why its new architecture is required, so the utilization of the cluster can be increased. So these are the major reasons because of that this cluster has been this new architecture has been introduced. So now let's move to the yarn and we will discuss the each component as much as possible. Let's move exactly on yarn. So the fundamental idea for yarn is to split the major responsibility of the job tracker. So we have visited job tracker, and job tracker has two major responsibility in the older version of framework. So that has been taken out from this job tracker, and one is resource management, and second is job scheduling and monitoring. This two responsibility like resource allocations and monitoring of job, even scheduling is done by this resource management, so and this is done by the application master. Monitoring, especially application master is responsible for monitoring your job. So this two responsibility has been given to the has been taken out from the job tracker and divided into two major components. There are two separate daemons. So these are called daemon, resource manager and the application master. Two separate daemons which are responsible of like handling the responsibility which was handled by the job tracker. So this is the major refactoring has been done in the yarn architecture. So remember, this is very important. Like if you are preparing for certification, this is very important point. Other than this two component, there is one more component has been introduced, that is node manager. So previously you have seen on each node, data node, there is a task tracker has been created, correct, which is responsible for tracking each task and monitoring each task. Now this has been replaced by the node manager. However, the like responsibility is divided in a separate way. So but you remember, like this is your resource manager is central component, and then there is a there is a node manager which is exactly is responsible for, there is another node manager, this two node manager. Okay, let's say for each even one more node manager you can introduce. So now this node manager communicates with the resource manager, and so resource manager plus node manager, that is per node slave. This is node manager would available on each node. Okay, so that is managing application in a distributed manner. So combination of resource manager and node manager will manage your overall cluster's resources. Okay, because node manager communicates with the resource manager. Okay, how we'll see. Resource manager is ultimate authority that arbitrates divisions of resources among all the applications in the system. So there are multiple application means MapReduce jobs. One of the example is this now responsibility of resource managers to distribute the resources to the each individual jobs. Now what is the responsibility of node manager, we'll discuss later on. So let's clean it out again and discuss its app. So this is resource manager, your central component, and this is application master which is running one of the MapReduce job. So what it says, like I want to run one MapReduce job, can please give me the resources as I want to run this job, and this is my requirement. Then what happens is like resource manager will look into the cluster, because resource manager has all full visibility of the cluster. So the resource manager, based on the various node managers communications, it has full visibility over the clusters. So this communication happens to a, so this visibility, so it says like I have this much resources, so there is the various things based on this resource would be allocated, which we will see in the later session. But here like resource managers say, okay, these resources are available on node 1 and node 2 to execute your job, so you can execute your job on node 1 and node 2. So now then application master contacts with the node 1 and node 2 for the resources expecting from the resource manager, and then require the resources from this node from this node 1 and node 2, and execute its job, whatever its name is, MapReduce job. Now during running this job, this task, whatever you say, task, mapper task and reducer task are being executed on this node manager on this node. So now node manager is responsible whatever container over created by the resource manager for this job. This node manager will take care of it, monitor this each container, and if anything going wrong or something, then this is completely monitored by the node manager, and whatever is being utilized. So whatever resource manager has given permission application master to use it, node manager also has those information. So application master can even try to use more memory. It is not possible because node manager is not allowing to use it. So node manager is responsible over here. Like application master would not acquire more resources which was already given to which is like whatever resource manager has given to this. So now this node manager is the monitoring does the monitoring over the individual node. So that is how the resource manager, node manager and containers each works with each other. We'll discuss in depth each component in detail. Here little bit it's complex, but we need to understand. So now resource manager has pluggable component. Now let me go back. So now this resource manager, like on what basis this allocate the resources? Like I have the 30 jobs to run, let's assume, and my first job requesting like give me the 200 GB RAM, which is like very high, and there is a 29 jobs in the queue which are waiting for this to be executed, which would be submitted after that. If all the memory is application manager master one has requested, then what happens with the other application master? So in such scenario, there is a one pluggable component in the resource manager that is called scheduler. So I'll just create a watch clock over here so you can understand. So this scheduler is what kind of scheduler has been used with the resource inside the resource manager? Based on this, that application master priority or execution permission or resources would be allocated. So that depends on the scheduler which is being used in the resource manager. So RM has a pluggable scheduler component which is responsible for allocating the resources to the various running applications in the cluster. Resource manager optimizes for the cluster utilization, keep all the resources in use all the time. So if there are huge number of jobs or even less number of jobs in the cluster, then resource manager will try to use 100% cluster all the time, because it don't want to waste any time or any job to be delayed. It wants to process all the job as fast as possible. So where is the resource available on the cluster? It has all the information with it. Whenever there's a cluster node goes down, up, new node is added, or whatever happens, there is always this information is available with the resource manager. So resource manager will try to use 100% cluster all the time. Okay, now resource manager is aware of current cluster capacity. Scheduler is pure scheduler. The scheduler is pure scheduler. It won't do other than it won't perform any monitoring or tracking or status of the application. It just allocate the resources based on the what kind of scheduler it is. There are various kind of scheduler. Let me give you the name. There's a capacity scheduler, there's a fair scheduler, there's capacity fair scheduler. So this kind of the scheduler which we are going to discuss in future session. So scheduler is, I will guarantee a restarting a failed task failed due to the application failure or hardware failure, but it is always responsible for scheduling the job only. How to schedule? Node manager is per machine slave. We have already discussed. So now node manager is responsible for launching the application containers. Okay, let me draw this diagram again. So this is your node manager. So inside the node, based on the application, there are various containers are created. So this one job would be running this container. This many containers can be used by the job one or application one. These two containers would be used by another job 2. This container is used by the job 3. So now this node manager's responsibility to launch this container in the cluster or kill this container as well. Node manager monitors container resources, CPU, memory, disk, etc. And same would be reported to the resource manager. So this is your resource manager. So this node manager always in contact with the using the heartbeat with the resource manager, so that it knows. So resource manager is always aware about the cluster's resource availability. And application master is responsible for negotiating appropriate resources, as we have already discussed, from the resource manager and their from the scheduler, and tracking their status and monitoring their progress. Okay, sorry. So application master is responsible for taking the resources from the resource manager and tracking the jobs and status and monitoring their progress as well. Application master runs as a normal container. Okay, application master runs on a normal. So let's take an image which I have taken from where on the website. Okay, so now this is clear pictures where this will give you the more. So this is resource manager, which is central component or your Hadoop cluster. This is client. There are two types of client, different colors symbolized over here. This each client submits a job. So there are two jobs are submitted in the cluster. Now this three nodes have been shown in the cluster 1, 2 and 3, and each node has a node manager running over here. You can say this 3 node manager is running. So now whenever the application master, so you can see here application master is a blue color. So this application master is also a container itself, because it also has a CPUs, memory and whatever. So application master is also launched as a container. Okay, but it's not exactly running your mapper task or reducer task, but it is responsible for managing your all applications. So this is app master. So now this is container. So these are containers which can be used. So this all are communicating with each other. So I will not repeat again the same thing. So MapReduce status is a darkened arrows. So each container app masters have been continuously in contact for getting the, and this job submission is done by this client, and then node status is reported back by the node manager. Then resource request, app master requesting the resources from the cluster. So this image shows the how this all communications is happening among the all components. So application master is an instance of a framework specific library. Okay, so we are discussing here the MapReduce job. So this app master is a framework specific library. So suppose you have written your job in Java. So this app master is actually containing your library and executing that Java code which you have submitted. Now you have written something that can be executed on Hadoop framework, that could be in C++, whatever you have written, or some other API or framework which is possible to run the in parallel processing can do. So this app master actually contains your actual code, actual library would be submitted to this app master, so it remains with the app master. So app master, application master is an user code has to not trust the application master. So resource manager will never believe on the application master, won't trust on the application master, because it is in a user code finally, and user can write anything, as you know, so which can consume whole cluster resources. So for that, resource manager's responsibility, like how to handle such kind of issues when user application masters is faulty code is submitted. Application master is not a privileged service. Resource manager and node manager has to protect itself from faulty or malicious application masters. Sorry, each application has its own application master. So suppose you are running 100 applications, then there would be 100 application master, but it is not always true, because Pig or Hive has also a different way they have implemented to optimize the things. So there is a lesser number of application master for the more number of MapReduce job. An application via application master can request any of the following resources, like it can request for resource name, host name, rack name, complex network topologies can be accessed, amount of memory can be accessed, CPUs can be requested, like number of CPU, number of cores of CPU, DEX, network, IO, GPUs and more can be requested by the app master from the resource manager. Yarn is designed to allow individual applications via application master to utilize cluster resources in a shared secure manner, because this is finally user library and user can do anything. So now this is resource manager is responsible and try and always make sure that everything runs in a secure manner. It also remains cluster topology aware, so resource manager has to aware about the cluster topology, because otherwise it won't be able to distribute the cluster resources properly. Application request for resources in the like resource name priority. Okay, let me go back. So resource can be requested from the cluster in this form. So this is say resource name priority. What is the priority is needed, that is this priority is for individual job only, inside the job only. Resource requirement, this is resource name, like resource name could be RAM, priority, whatever you can say, we'll see this later on. Resource requirement like 20 GB, sorry, you can write here 20 GB, or number of containers, how many such container, 100 containers, whatever. So it can request this. So this way its resource manager will see overall cluster and assign these many resources to the app master. Number of containers, how many such containers about. The security, for the security reason, the container allocation is verified. So as I have said, because the application master can request anything, so it has to be first verified in a secure mode to ensure application master cannot make a fake allocation in the cluster. Application master can launch in a container, which is could be command line, shell script, environment variables, C++ jobs, local resource such as jar, data files, etc., and security related tokens can be executed by this application master. So that's about the very initial introductions about the yarn. So thanks for listening, and we'll discuss more about yarn in the future sessions. Thanks for listening.